Hi everyone, welcome to video number 3. Today we're going to be exploring the atomic structure. So in the last video we met many atoms in the periodic table, and today we're going to be going a little deeper into the subatomic particles which make up atoms. So there are three main subatomic particles that we need to be aware of: protons, neutrons, and electrons. So we have a table here that gives us some basic information about the properties of these subatomic particles. So protons have a relative mass of 1. Neutrons also have a relative mass of 1. Electrons are considered to have no mass, so relative mass of 0. It's actually extremely small, but for our purposes we can consider it to be negligible. So the charge of a proton, plus 1. The charge of a neutron, there's no charge on a neutron. And the charge on an electron is negative, minus 1. The location of the proton is within the nucleus of the atom. The location of the neutron is also within the nucleus. And the location of the electrons, well, these exist in shells or orbitals around the nucleus. So in the periodic table, you would have seen some numbers written to the top and bottom left of the symbols of the atoms. So for example, carbon, okay? So carbon has the number 12 written at the top left and the number 6 written at the bottom left. So what do these numbers stand for? Well, 12 refers to the mass number of this atom. 6 refers to the atomic number of this atom. So what do these numbers mean? The mass number is equal to the number of protons plus the number of neutrons. So the mass number, because if we remember, protons and neutrons exist in the nucleus, the mass number therefore gives us the mass of the nucleus of the atom. The atomic number gives us the number of protons. We can look at another example to exemplify mass number and atomic number. We can use phosphorus. So phosphorus has a mass number of 31 and atomic number of 15. So if we take the mass number and we minus the atomic number, 31 minus 15, we get 16. So 16 is the number of neutrons . 16 is the number of neutrons in the nucleus of a phosphorus atom. So we can represent atoms like this. We have the nucleus, we have our first shell, and we have our second shell. Now I'm going to draw oxygen, okay? So oxygen has an atomic number of 8. So we have 2 electrons in the first shell, and we have 6 electrons in the second shell. Now, the nucleus contains the positive protons and the neutral neutrons, and therefore the nucleus is positively charged. The electrons are negatively charged. So the electrostatic force of attraction between the positive nucleus and the negative electrons holds the atoms together. Now, the closer an electron is to the nucleus, the stronger the force of attraction, and therefore the more stable it is. The further away from the nucleus, the less is the attraction, and therefore the less stable it is. So electrons that are located in the outermost shells participate in bonding with other atoms, and these are called valence electrons. Valence electrons exist in the outermost shell. So based on this diagram we've drawn here, oxygen has 6 valence electrons, and you might be wondering, why did we put 2 electrons in the first shell and then we put 6 in the second shell? And that's a great question. And we're going to look at why we've done this in the next video when we look at electronic configuration. So I'd like to wrap up this video by talking a little bit about isotopes. So the definition of an isotope is that it is the member of a family of an element that has the same number of protons but different numbers of neutrons. So that means that isotopes have the same atomic number but different mass numbers. For example, I can have carbon-12, carbon-13, and carbon-14. We're all accustomed with carbon-12 because basically we have carbon-12 having 6 protons and 6 neutrons. Carbon-13 has 6 protons and 7 neutrons. Carbon-14 has 6 protons and 8 neutrons. So these are all isotopes of carbon. Now that does not mean that they belong to a different element. They're all still carbon. The element is determined by the atomic number, and the atomic number here is the same. However, isotopes of elements have different properties. For example, carbon-14 is radioactive and is used to, for example, determine the age of fossils in a process known as carbon dating. So that's about all we're going to talk about today regarding the atomic structure. I hope that this has clarified for us protons, neutrons, and electrons. And I'll see you guys in the next video where we're going to look at electronic configuration.